Good afternoon. How's everybody doing? Okay, this session is on WebSocket perspectives, and we're going to talk a little bit about WebSockets and clouds and streaming and microservices and all kinds of cool stuff. And I'm speaking with my colleague, Peter Moskovits. And just a quick background. So we both work for Kaazing, and for me, I actually chair the Java user group. Don't hold that against me. I'll be back next week when Java 1's in town too. I also chair the New York HTML5 user group in New York, so that's pretty active. So that's great. Certainly not as active as the San Francisco one, which has like 10,000 or 12,000. With Peter and Vanessa running that one. And here's my colleague Peter.
Thank you, Frank. My name is Peter Moskovits, and I'm head of real-time solutions at Kaazing. Kaazing is a startup, has been around for 7-8 years. We are down in San Jose. And as you may know, our founders have been instrumental in crafting and contributing to the WebSocket standard, as we all know and love today. My job at Kaazing is to speak at events like this and inspire people like you about the technology and what you can achieve with that. So I'm going to show you a handful of, I think, pretty interesting things that we can do. And before we get started, I wanted to let you know that we have a couple of copies of the very first book on the WebSocket technology. That is a purely technological book. If you are interested in participating in a raffle, we are going to raffle off 3 copies of this book at the end of the presentation. Then on the bottom, in the footer, you see the URL. You can sign up and we'll do the raffle at the end. The flow of the book reflects some of the very interesting concepts that we are going to talk about in the presentation, so it might be relevant to many of you.
Thank you, Peter. And also I want to thank Ann for this great conference. This is the 6th year we've been here, so thank you very much, Ann. Okay, so that's our outline. We're going to go pretty quickly, so hope you guys had your coffee. So let's talk about web communications and where does WebSocket fit in all this. So we know that how the web works. Okay, we have browsers talking to web servers and some application or some services on the other side. And you remember those little counters you used to have on web pages, right? They're like, your visitor 1,234. Remember those just a few years ago? Well, it's a little different nowadays. So what's replaced that now are web APIs. And I know that we all deal with browsers on a daily basis, but most of the web is not visible, right? We know that. So, and there's actually the dark web. So I found a little stat, like 10%, one site said 10% of the web is just used by APIs, but then I found another site that said that because of the dark web and the secure web and some other types of webs, that it's actually, the amount of searchable information is like less than 1%, which is kind of crazy. But my point here is that most of the web is used by APIs, and we're talking about $1 billion industry, multiple billions of dollars. I mean, when the CEO of Expedia or eBay say that their business is billions of dollars and there's no browser, then we're talking about multi-billions of dollars. And for many people that deal with CSS on a daily basis, comes as a bit of a shock, right? And we know that actually, how many people have used server-side? I'm not talking about APIs in a browser, but services. How many people use APIs out there? Good. Most of you. So we know about the growth. I mean, we're talking about crazy, crazy growth. And instead of saying your visitor, 1,234, we're now talking about billions of hits, not hits, excuse me, API calls. So when like Twitter does like 17 to 20 billion API calls per day, well, this is pretty loud. It's a significant difference than just talking about hits, right? We're talking about services and API calls. So it's a different world now, right? It's a different world. And if you go to a programmable web, which has some really, really good research on API calls, there's a listing of 14,000, at least, actually it's over 14,000 public APIs, and everybody's offering these APIs, right? And these are just the public APIs. The number of private APIs is probably twice that, if not more. And these are primarily REST-based APIs, probably over 95% are REST-based. But now over time, we're going to see more and more event-based APIs, and we'll talk about that. But this is pretty cool. I mean, there's a lot of APIs from some trivial uses to some more significant ones. And here's a trivial use. So I just did this purposely from the command line, not showing a browser. And here I use a simple call to get some data, and you can see what kind of jokey data you get. I mean, this is a real website, believe it or not. I don't know if somebody actually spent time creating this database, but it's a Chuck Norris database. So there's some trivial, well, not trivial. I had a good laugh out of it, so it's not trivial. It was a fun service. There's more serious services, and here's like using GitHub. And I wrote this little tiny script to go to GitHub and find out the amount of forks in a repo. I mean, it just took me like a few seconds to write, thanks to my Unix training from Bell Labs years ago. But this is a more useful purpose. The point about this is that I'm using the command line, right? I'm not using a browser. I'm using a service that's out there from the command line. Didn't use a browser. And since I run the Java user group, and based upon different events that happen, we use Amazon, AWS. I could spin up services based upon, we might have a big name speaker coming. I might have to spin up more instances to support whatever event we come up, that comes up. I use scripts on my Mac to do that. I don't go to the AWS. How many people use AWS? Right, you go to the little console, to EC2 console, right? Most of you do that. You can certainly do that for the scripts. You download the AWS API to your Mac or other types of machines, and you can control everything through APIs, right? That's what a cloud is. A cloud is a programmable data center. So I do that from scripts and using cron on my Mac. So it's very, very cool. The important thing is that this is services integration. So it's a little different from some of you that deal with web design. This is services integration, and I'm not using a browser. Okay, so remember that. So why am I talking about that? Because why it's important. Well, services is integration because that's the way the world works. Services integration is critical, right? This is how you leverage things that are out there, other services. It's not just by typing the URL and viewing a page, right? It's very important. System integration is ultra important, especially for big companies. And it's also important, we know about REST, right, and other calls. REST is what's called a synchronous call, right? You make a request, you wait, and you come back. You make a request, and you wait, and you come back. So it's called asynchronous. You're synchronizing for the result to come back. Okay. Now, what happens with synchronous and the other alternative, or that's redundant, the alternative is asynchronous, where you don't have to wait. Just let me know when you get the answer, right? As opposed to, it's like having kids in the back seat saying, are we there yet? Are we there yet? Are we there yet? Are we there yet? So you're not going to do that. You're not going to pull, right? So I've been around quite a while. You can tell from the white hair in my head. There's a repeating cycle. Sounds like a sci-fi movie, but you're caught in this endless loop. There's often a synchronous phenomenon, synchronous way of doing things, and then right after that follows an asynchronous. Then it becomes another synchronous thing, and what follows quickly? Another asynchronous way. It just seems like there was this pattern. Every 10 years this happens, right? So we have REST. REST is synchronous. People are starting to ask about, I don't want to wait. There might be a long calculation, a long analytics calculation. I don't want to wait, so let me know later. Or it might be publish, subscribe. I want to subscribe to things. I'm going to wait till you tell me when something happens. So we don't want to be stuck in this bad sci-fi movie over and over again, right? We want to break out of this. So if you follow things that are maybe not quite so webbish, but there's a trend called reactive programming. In other words, it's dealing with streams of data, dealing with events, things that happen, right? The real world. All kinds of trends. I mean, you've heard of Spark and Big Data World and Kafka. These are really, really important things. And they're growing in popularity. So it used to be synchronous things were growing in popularity. Well, we've dealt with that for the past few years. Now we're dealing with asynchronous things. So even Java, I mean, you can criticize Java, and I'm sure this crowd will criticize Java, but Java 8 now has things called lambdas. And we're talking about reactive programming, and we're talking about, there's a variant called functional reactive programming, which we won't get into, but it's basically we're dealing with events and streams of data, right? This is very, very important. So what web models do we have to deal with streams of data? Well, we have good old HTTP, right? It's been around since '97. And now lately we have HTTP 2, which adds all kinds of cool stuff. You know, it adds binary and compression. Actually, I think somebody correct me, I think it used to use gzip, and it no longer uses gzip. Somebody told me this morning. No, okay. As far as I know, it doesn't use gzip. But it's certainly, you can get reportedly 30 to 50% more performance. So that's a cool thing. And I actually put SSE, and for people here in this audience, you should be familiar with SSE, server-sent events. That's effectively a standardization of Comet techniques, right? Comet was never standardized. It was just a loose collection of techniques to do server push, and it served us really, really well. I mean, it's a legacy thing now, but SSE is the formalization of Comet. And then we have WebSocket on the bottom, which was standardized as of December 2011. So it's the official protocol for the web. How many people use WebSocket on their pages and sites? Okay. That's not that many. You guys know it is a standard protocol, right? Okay. Now, I started to research some additional frameworks and mechanisms for doing event, and I found so many of them. I mean, so I just listed a few of them. Of course, everybody knows about Node, which is a really cool way of doing JavaScript on the server side as well as the client side, and it's a partner in crime, Socket.io, and Engine.io, I believe, too. There are also standard things, like we have web notifications and we have the push API. So the W3C has recognized this trend, and now there are additional standards for doing simple notifications and simple push APIs. I mean, we're familiar with APNS and other simple notification APIs, so now it's web standard. So what happened to WebSocket on all this? So where do I use WebSocket? So WebSocket, certainly it's not a REST replacement. People have talked about, okay, replace REST. No, not really. I mean, REST is cool for certain things. It's very simple, right? It's like an RPC over the web. It's very, very simple. And it's not going to replace HTTP either. HTTP is fantastic for a lot of things. It's going to be with us for the rest of our lives. It's great for caching stuff, for static data. Really, really cool. But it's complementary to HTTP and also to REST, which REST uses HTTP. It's complementary. Now, for simple notifications over the web, you know, for the past few years, people have said, well, we can use WebSocket for notifications. You can, but there are so many simple techniques, frameworks, libraries to do this over the web now. If it's something simple and you don't care if actually the user got it or not, you know, a simple notification, don't use WebSocket. Use something that's, you know, like the push API, notification API. There's many ways of doing that. Where you use WebSocket is when you want a full duplex, and remember from our Computer Science 101, full duplex is bidirectional at the same time, right? So use it when you want a persistent connection, so you're always connected, and you're full duplex. That's where you want WebSocket. So think of WebSocket as a TCP for the web. Now, we know it's not TCP, right? HTTP and WebSocket both sit on top of TCP, right? But consider it a TCP for the web. Client server over the web, a web-friendly client server. And for a lot of non-browser use cases, it gets really, really interesting. And you can get WebSocket servers from many different locations. There's like 100 implementations of WebSocket. They're 100% whole open source. We have a great WebSocket server you can download. And when I say TCP for the web, what I mean is that if you consider it as a transport layer, right? If you consider it as a transport layer, I mean, there's 5 method calls for WebSocket, right? Sounds like it should be easy, right? There's 5 method calls. But there's a lot of additional intelligence that you need on top of that. It's just like going back to when TCP was first invented. Okay, there's very few calls you can make. It sounds like, wow, should be trivially easy. So you do that, but then the next day, like, well, how do I add this, and how do I add retries? How do I add, if the client's too slow, how do I add publish subscribe semantics? How do I do this? So even though you have a simple set of APIs, and that was designed to be that way, because you could build things on top of the simple stuff, right? So if you can do that, and you could implement other protocols, other APIs on top of WebSocket, what do you get? Well, if you can do JMS and XMPP, et cetera, et cetera, et cetera, you now can program with those APIs and make it work over the web through port 80, right? So this is really, really cool. And again, the protocols are the key to integration, right? We're talking about services and protocols. Right, so all these protocols give us all kinds of cool additional functionality that you just don't get with the low level. I mean, with WebSocket, it's, if I remember correctly, it's send and on message, right? There's 5 calls, right? The ones that are important, obviously open and close, but send and then on message, or receiving a message. But then how do I add all this cool stuff, not cool stuff, but important stuff on top of those 5 calls? It's a lot of work. But that's what protocols give us, and they gave us to us like for the past 40, 50 years. So why can't we leverage all that? So as we talked about Internet of Things earlier today in a presentation, one of our colleagues talked about that. And we know that the world is naturally event-based. The world is not synchronous, right? We talk about like rest was synchronous. The world is not synchronous. And if you go to the W3C, you'll see this nice diagram. And look at the title. The W3C says it's not about the devices. I know it's kind of cool to look at the devices. Wow, that's a really cool thing there. That's a really cool thing there. It's not about the devices, oddly enough. It's about the services. And if you go to the W3C, they will say that verbatim. It's about the services, not the devices. This is really, really important. So it's a little jokey thing here, the web of things. What does it have to do with the web? Well, IoT has a lot of different protocol standards. There's no formal API to control everything. If you don't have a common API, how do you do composition, right? There's a lot of issues with IoT. So what the web does, and I apologize for the wordiness of this slide, but it applies all the benefits we know about the web, that the web has given us since '89, if I remember, '89. It gives us reachability, right? And it gives us ease of development. Well, that's what the web of things gives us over the Internet of Things. And there are now standards for the web of things, right? There are formal standards for the web of things where big name companies, as you would imagine, the big device companies are participating in. Now, the thing that you have to think about, you have HTTP. Don't automatically think that HTTP is the answer for IoT. It may be, but you have an alternative in WebSocket for certain use cases. So don't always assume it's HTTP. HTTP has a lot of advantages just for a lot of use cases. For other use cases where you want a persistent connection, you want to do publish subscribe, and in other places, you might want to use WebSocket or something built on top of WebSocket. Right, and there's now books on talking about the IoT and Web of Things where it might not be synchronous because it's a little different, right? The top diagram is that the human web is where we're sending data to the human, to the browser, right? In the Web of Things, it's typically, not always, typically you're sending data from the endpoints to the server. So it's a little different. Okay, now a few slides on microservices, then I'll turn it over to my colleague Peter. So how many people have heard of microservices? Okay, it's a very popular term, probably heard of Docker, right? So for those that don't know about microservices, it's nothing new, right? It's the old saying about breaking a big problem into small problems. I mean, Socrates said that probably. And no, I wasn't there with Socrates. It's basically a lightweight, it's a derivative of services-oriented architecture. There's nothing really micro about microservices. It's just like, when you talk about big data, the word big helps marketing of big data. It's more about the analytics of the data more than the size of the data. The same thing with microservices. It's not about the size of the service. Just take the word micro out and throw it out. It's not really that. It's having a collection of services to build an application. Micro just, honestly, in my opinion, micro just helps it market a little bit better. And it's just breaking a big problem to small problems, right? So we don't want necessarily a monolith. Sometimes monoliths are good, depends on your team, right? When you're a manager of a team, you have to look at your team's, their expertise and say, well, can they handle microservices? Can they handle monolith? Maybe monolith isn't bad, but not necessarily bad. So microservices is using a good old Unix philosophy of small is good, right? And then like there's a pipeline in the center. This is the same thing. It's basically the same thing. It's creating little tools and collecting the tools together. Now the spin is that it works off of, it's a riff off of virtual machines. And we know on the left, here's a set of virtual machines, virtualization, I should say. And on the right, well, a virtual machine can be spun up in about 5 minutes, right? In Amazon, five minutes. Well, if you have the same OS and you're using similar, you're sharing a kernel, why do you have to spin up the OS? Why don't you share the kernel? So instead of spending 5 to 7 minutes spinning up a VM, you could spin up a microservice in literally a second. And the difference is, I mean, the architecture of small is good has been around for decades. That's not what's innovative about this. It's about the container and about isolation. Right? We've had isolation before years ago, but it was very loose isolation. I mean, it was like, I remember something called chroot in Unix, ch root, like change the root to a different root. Well, that's sort of isolation, but then anybody can, I'm sharing a machine with other people, so it's not really isolation, right? So I'm sharing the file system with other people. Well, it's not really, sharing file system, sharing CPU. So the more modern microservices where you get true isolation. Okay, now I'm getting to the punchline with this. So there's a lot of advantages for microservices, and certainly you can get this presentation later on. But there's a lot of advantages to microservices. Now here's the point about microservices. So when you go to Amazon.com, and Amazon uses a microservices architecture, 150 to 200 microservices calls get fired off when you visit to personalize it for you. Right? That's a lot of calls, 150 to 200 microservices calls. Now, Amazon's quite the leader in that space. We've talked to other big companies that do similar e-commerce sites, and they have microservices calls. But all these calls are REST-based. So if you have to fire off all these calls, and they're synchronous, and some of them are chained, where this one calls that one calls this one, and they're all REST-based, there's a lot of additional latency in the overall architecture, because you have to wait for results. So this is a problem. So we've had many companies talk to us and say, like, how can we, solve this problem? Well, certainly using synchronous might be a problem, right? Maybe if you switch to an asynchronous approach, it might be a little bit better. So sections of the page can operate asynchronously. The chaining could occur asynchronously, and you want to, so that increases your scalability, where scalability is growth divided by complexity. Okay, so I think instead of talking about cloud, I think I'm going to let my colleague Peter talk about cloud. So Peter.
Excellent. Thank you, Frank. So we've seen a lot of interesting concepts, and I would like to take you to a journey of how we've been trying to stretch the limits of what you can achieve with WebSocket. But before doing that, I wanted to flash up this URL again if you wanted to sign up for the free book. So I'm going to walk you through 4 different stages that we have seen in the last couple of years. The first one is the one that probably most of you are so familiar with, the notion of having a browser that is the client that's connecting to a server and has a long-lasting permanent connection to the server that allows the server to send data and allows the client to send data back. So if I asked you, probably most of you would be familiar with the to-do MVC example. The to-do MVC is kind of the canonical HTML file or JavaScript front-end framework application that most framework provides. So let me open up this app in 2 browsers, assuming that we still have a mouse. Here we go. So what we have done is we took the Angular version of this to-do MVC application. Most frameworks have their own flavor, and we added real-time capabilities to it. The only reason why I'm showing this to you is because if you want to familiarize yourself with Kaazing as a real-time technology, this is probably a good way to get started. So I add an item to my to-do list. It was bread. It shows up in the other one. I add a second one here that shows up over there. I can hover over these items. As I hover, I can see it in the other browser window. I can check them off. They disappear. So what is happening here is that as I'm interacting in one browser, that information gets published to the WebSocket server, and anybody who is interested, who is subscribed to that data flow, will receive that and can update their UI accordingly. Frank mentioned the notion and the importance of events. This is all about the event-driven way of building applications on the web without making compromises that we were forced to make in the world of HTTP and REST. Okay, so let's move on to the next interesting scenario. The second one is not only can you build browser-based applications, but you can also build native applications, whether these are native mobile apps that are running on our devices or native desktop apps built in .NET or Java. I wanted to show you an example that one of our customer has built and is providing today. And let me try to find my desktop here. So what you see here, this is the largest car racing franchise in the US. They provide a second screen application. As you're watching the race happening on live TV, you can have your tablet or your phone out, and you can render a virtual 3D world of that same race. Here, there's more than 100 sensors on each car, and the races tend to run for 3.5 hours, and we are sending billions of messages, over 3 billion messages during one race. Here you can sit in a car, you can look forward, you can look backwards, you can see that all the other cars are rendered in real time. And what's special about this experience is that as you are watching this race on live TV, on your tablet, it's so real time that it's actually faster than real time. It's faster than live TV. So you see things happen here before you see it on live TV. Okay, let's move on to the next one. The third one is, and here are some statistics about the number of messages that are sent by Twitter. Twitter sends about 500 million messages a day. We send over 1 billion messages in an hour during these races. The next one I wanted to mention is IoT. Frank touched upon this. IoT is extremely interesting to us because it dramatically increases the number of clients that are out there that are capable of send messages. Typically, messages are coming from the edge towards the data center. But there are other interesting use cases as well when you control physical devices that are out there in the edge. So I wanted to show you what we did here. We have been following the news, and there were some very sad news lately in the last year or year and a half where as airplanes are flying by the tens of thousands around. Every now and then they disappear. And the best way we seem to be able to do today is to record the flight data into the black box. And when the flight disappears, the black box disappears along with that. So that made us think, and we figured, is there a way to stream that data, to get that data off the airplane in real time? So what we have decided to do is we couldn't quite buy a commercial airliner, but we bought a quadcopter. So this is a DJI Phantom 2 quadcopter. And I'm not going to fly it here, but what we did was we attached a number of sensors to this quadcopter to simulate an airplane, a commercial airliner. This is an Arduino-based sensor stack. It has temperature, humidity, accelerometer, GPS attached to it. And we wanted to see what it would take to take that data off the quadcopter, use a satellite connection to get it to some sort of a data center, and then distribute that data over the public web. So let me show you what we ended up with. So what we have done is we flew the quadcopter. It can fly 700, 800 meters, 2,400 feet high, and we connected it to a British Inmarsat geostationary satellite network. And we transferred the data from here in California to London, and we measured the latency. How long does it take to get the data from California to the UK over the satellite connection? And what we found was that it's about 600, 650 milliseconds to get it to London. Then we took that data, and from London over the public web, we distributed it to all sorts of clients. These clients can be air traffic controllers, aircraft manufacturers, all sorts of authorities, or even the general public. And then we measured the latency to what it takes to get that data to the slowest corners of the web, and we found that it's around 300, 350 milliseconds. So what it means is that if there is an airplane that's flying over the Indian Ocean and is making a left turn, and you are sitting with a tablet in your hand on Antarctica at the Norwegian research station that's connected to Wi-Fi, in less than a second, you can know that that plane made a turn. So that's impressive what you can use when you have the right tools available to you to communicate. And this is all happening over the public web today. So here is a brief video so you get an idea what was built here. Here you see the quadcopter has the box attached to it. The box contains all the sensors, all the Arduino sensors, and this is the dashboard that we built. In the middle, there is a compass. In the background, you see the map. Every now and then, a map is going to move a little pixel left and right. In the middle, you see tilt and pitch indicators. On the left-hand side, you see speed. On the right-hand side, you see altitude. And the video was edited into this experience later on. We did not transmit the video, but we did transfer the telemetry data over this satellite connection, over WebSocket, over JMS. So wanted to show you as an interesting or somewhat unusual example. And this takes us to our final example, where, again, we are in the business of stretching the capabilities, what you can do with the technology. So we have talked about different kinds of clients. We talked about browser-based client, we talked about native client, we talked about IoT-based client. How about we try to connect two servers together, multiple servers? So let me give you a little context about this one. The idea is that we have all these cloud deployments out there. Some of our services are in one kind of cloud, some other services in another cloud, but some third kinds of services we are not quite comfortable getting into the cloud, and we keep them on-premise. What are the ways to provide connectivity between clouds and on-premise or applications that are running in different kinds of clouds? A typical answer is that you would create a VPN connection between these networks and you connect them. But VPN has a number of challenges. First of all, it connects the full network. You have to open up ports on your firewalls. And it's not specific to the applications that you are trying to connect. It's kind of a generic level connectivity. So the question that occurred to us, is there a better way to solve this problem? So here is what we have come up with. If you take a Kaazing server, a WebSocket server, and you deploy it on-premise, and you take another server and you deploy it, or in the cloud, sorry, on the right-hand side, and on-premise over on the left-hand side, then between these two servers, you can very easily create a permanent bidirectional full-duplex connectivity. You provide one endpoint to your application in the cloud, and you provide the target over on the on-premise side, and basically you have the ability to tunnel the information over from the cloud all the way to the backend. So a typical example is that on-premise you have your LDAP repository, your Active Directory server, and you need to reach back from the cloud for authentication or authorization purposes. And what you can do when we named this packaging or this product suite Kaazing WebSocket Intercloud Connect Quick, what you can do is you can have an app-to-app connectivity, not a network-to-network, but specific app-to-app connectivity with a specific port being connected from one end to another. And you can do this with having your firewalls completely shut down. That means that no inbound ports on your firewall are open. All the connections that are getting established are done from the inside outbound. And when you do this, you get a way more secure connection between your applications running in the cloud and your applications running in another cloud or on-premise. It's an app-to-app protocol-specific connectivity. Okay. So these were the 4 scenarios I wanted to walk you through: browser, native applications, IoT kinds of applications, and server-to-server or network connectivity capabilities. While you are getting ready to ask your questions, the time has come for us to raffle off the 3 books that we have here. And the way we are going to do it is the following. I am going to try to bring up the page where you have signed up. So maybe you can find your name. You can see your name here. It looks like we have 50 people who have signed up. So we are going to, sorry? 49, because it started at 2, exactly. Thank you. Nice catch. Oops, there is somebody else. 51. So I'm going to run a quick random generation, random number. We are going to generate one random number between 2 and 52. And here we go. Number 7 is our first winner. Number 7 is Ross Martin. Do we have Ross in the room? Excellent. You are the first winner. Second winner is going to be number 34. And that is Scott Milton. Do we have Scott in the room? Excellent. And the third one is 46. Number 46 is Cody. Do we have Cody in the room? Excellent. Okay. So this concludes the planned part of the presentation. I wanted to put up our contact information. Please feel free to get in touch with us. We are at the orange table back there right at the entrance. We have some of our engineers, solution architects, and even our CTO in town. So if you have any questions, please come by and ask. And we may have a minute or 2 for quick questions if there are any. Yes, there's a question. That's for you, Frank. Go ahead.
You talked about the firewalls, right? So can you talk more about why there are no inbound connections required?
Yes. So the direction in which the typical data flows is reverse to how we establish that communication. So think one analogous way to think about this is that you have two phones. One has the dial on it, the other one does not. The one that doesn't have the dial cannot dial anywhere. It cannot make phone calls. It's only the one on this side can make that the phone call. But once the phone call, the line has been established, you do have a bidirectional communication channel. I can talk and you can talk. So it's kind of similar to this. It allows you to completely shut down all the inbound ports of your firewall. So unlike in the world of VPN, where you do need to have it open, the connection is established from the inside out. So the outbound port is open, but from the outside, it's locked down. Okay, one more question? Yes.
That's the answer.
Yep.
It's by default.
Final question?
Services transmit the aircraft telemetry. Why don't you use
Do you want to take this?
TCP or why much?
Your question is why use WebSocket instead of TCP?
Why use WebSockets to send telemetry on aircraft? Why not use standard TCP/IP or something?
Yeah, that's a good question. The trend that we are seeing is that data is distributed over the web. The web is used as the means for transferring information from A to B. Traditionally, we have used leased lines, we have used dedicated radio channels, we have used all sorts of custom ways to get data from A to B. But as the web becomes and became ubiquitous, that is kind of the trend that we are just using the web to get data from A to B, whether it's banking or whether it's between data centers or any kind of communication. And as long as it is resilient enough, secure enough, and you don't have to make compromises from a functional perspective, that is the cheapest and the best way to do it. And now, with this open industry standard, you can do this. So this was a proof point to justify that this is a definitely viable way of doing things. Okay. Well, thank you very much for coming to this talk. And again, feel free to stop by if you have any questions.